2, there are total number of courses you have to take. Equal from 0 to number of courses minus 1. You're given an array prerequisites where prerequisites I equal to AI, BI indicates that you must take course BI first if you want to take course AI. Okay. So I think okay. B, in this case, we can model this to a directed graph. B point to A means B is a prerequisite of A. Return the ordering of courses you should take to finish all courses. If there are many value answers, return any of them. If it's impossible, return an empty array. Okay, so for this problem, there is dependency relationships between different courses. Some must happen before others. I'll model it as a directed graph. And edge from x to y means x is the prerequisite of y. So this is a topological sort problem. We need to find a valid linear ordering or detect a cycle that make the ordering impossible. I'll use Kant's algorithm. First, I compute the integrate of every node. Integrate of any node means for each node how many integrates there are, aka how many prerequisites there are. And then I start the queue with every node that has integrate 0, means that it has no unmet dependencies. Then I do BFS, pop a node, add it to my result. And for each node, it unlocks, decrement the node's integrate. If a node's integrate drops 0, that means all the dependencies are satisfied, so it joins the queue. After I process all the nodes found, I have a valid order. If I process fewer than the total, some nodes never reached integrate 0. That means that we are stuck in the cycle. Now I think I can code it up. Start to create the graph, initialize it. For the course prerequisite. Also note that the graph is going to be course, and then a list of course that is going to be unlocked. So it'll be like this. Now we set up the course schedule. We just record completed equals 0, and also the answer of the order start with an empty one. Also, we are going to create a queue for the BFS. We initialize the queue with the element that it does not have any prerequisite to start with. Just check if someone's integrate is 0. If it's 0, that means okay. That means we are going to append it to the queue. We do the BFS. Of course, it's possible that there's no courses that does not require prerequisite, which makes it impossible. We definitely need to check whether the completed is equal to courses. If it is, that means okay, we are going to return the answer. There is a valid answer. If it's not equal, just return the empty one. Okay, now we see what's the current course. Current course is here. And then we got the current course. We wanted to update the completed, and also append it to the answer. Of course, we need to update the integrate to make sure everything that's a later course of this prerequisite got notified. Let's call it unlocked course. Unlocked in every course we are going to just decrement. Okay. In this case, start wrong. Okay. Oh no. Oh, so what's wrong with this? We forgot to decrement to check if the integrates must be 0. If it is Q append unlocked. Okay, awesome, finish. So for the time complexity, so while we creating the graph, we have O of E, and when we initialize the Q, we have O of V, and when we do the BFS, it's O of E, so O of E plus O of V plus O of V plus O of E. So in the while loop, each node will be popped left for at least for almost once. So it will be O of V, and for the inner loop, the for it is at most going to pop one time. So the entire graph, the worst case in the entire graph, everyone is popped one, so it's O of V plus E. So in this case, time complexity is O of V plus E. For the space complexity, we use a graph, and the graph will take O of E, and the integrate O of V, and the Q and the order almost O of V, so they together V plus E.